Hi Chem, today we're going over section 10.13 in CK12, and this is determining molecular formulas. So last week we were able to figure out how to determine the empirical formula. Today we're going to figure out how to do the molecular formula. So the point of having or knowing a molecular formula is that two compounds that are different can have the same empirical formula. So we can't really identify compounds based on their empirical formula, so that's where molecular formula comes in. So like glucose and sucrose, really all sugars, have a very similar structure, and usually they have similar empirical formulas as well. But they are very different in structure and everything. So this is sucrose and glucose. This compound has what we call, it has like a hexagonal shape. So like we have a ring of carbons, that's what these shapes are showing, whereas other sugars might have a straight line of carbons. So very different structures, very different compounds, but similar empirical formulas. So molecular formulas specifically give the kind and number of atoms of each element present in a molecular compound, not just the lowest whole number ratio. In some cases, but not all, the empirical formula and molecular formula are equal. So methane, for example, CH4 is its molecular formula. We can't reduce any further, so it's also its empirical formula. But acetic acid, which is vinegar, basically, C2H4O2, that empirical formula is going to be different than the molecular formula. The empirical formula is going to be CH2O. Its molecular formula is C2H4O2. And sucrose as well. It's going to have a different empirical formula than molecular formula. We can reduce these down to CH2O as well. So acetic acid and sucrose have the same empirical formula, but very different molecular formulas. Remember, empirical formulas, we can determine those by percent composition. To find the molecular formula, we need a little bit more information. So we need not only the empirical formula, but we also need to know the molar mass of a compound. Okay, so the molar mass of the compound is really the information that is vital to figure out the molecular formula. Sometimes we might be given percent composition and the molar mass of the compound, and we have to determine the molecular formula, which would mean that we have to find the empirical formula based on the percent composition, and then use the molar mass of the compound to figure out what the molecular formula is. So how do chemists determine what the molar mass of an unknown compound is? They use a machine called a mass spectrometer that determines the molar mass of an unknown compound. So this is what a mass spec looks like. Usually you put a sample, typically like a liquid sample. You can also have like gaseous samples as well. You put that into the machine. The machine analyzes it, and then it is connected to a computer that basically gives you a graph or an output of the analysis of the compound. So chemical analysis do this every day. They're really neat machines, but that's how they do it. You won't have to like look at something, and unless you're given a formula, you can't really determine the molar mass of an unknown compound. So you can't really just like look at something and know. You have to use an analytical machine. So here are the steps to go from the empirical formula to the molecular formula. So sometimes you might have to do the steps to find the empirical formula and then do these steps. But if the empirical formula is given to you, then you just follow these steps to find the molecular formula. So first, you're going to find the empirical formula mass, which is just the molar mass of the empirical formula. Pretty straightforward. So you use the values given to you on the periodic table to find the empirical formula mass for a given empirical formula. Next, you divide the molar mass of the compound, which again is given, that comes from the analytical machine. You divide that by the empirical formula mass. The result should be some whole number ratio or very close to a whole number. Then you multiply all the subscripts in the empirical formula by that whole number that you got in step 2. This is the molecular formula. So let's go ahead and consider an example. We have an empirical formula of a compound made of boron and hydrogen that's BH3. Its molar mass is 27.7 grams per mole. Determine the molecular formula of the compound. So first we want to list what we know and what we're trying to find. So we know that the empirical formula is BH3. We know the molar mass of the compound is 27.7 grams per mole. We're looking for the empirical formula mass. That's not given, something we gotta calculate. And we're looking for the molecular formula, which is going to be B something, H something. And it's going to reduce to BH3. So step 2 is going to be to calculate. First, we want to find the empirical formula mass. So we're going to add together 1 boron, which is 10.81 grams, plus 3 hydrogens, which is going to be 3 times 1.008 grams. So that gives us a total formula mass of 13.83 grams per mole. Next, we want to divide the molar mass by the empirical formula mass, which I just abbreviate as EFM. So we take 27.7 divided by 13.3, and we get 2. Okay, so this is the whole number that we are then going to apply to the empirical formula to find the molecular formula. So it should be B2H6, because 2 times 1 is 2, 2 times 3 is 6. Now if we did this and we got a result of 1, then we would know that the molecular formula is the same as the empirical formula. So the molecular formula would be BH3 if we got 1 for the result. So that's what happens if you get 1. So for review, what is the difference between empirical formula and molecular formula? What do they tell us? What do they not tell us? In addition to elemental analysis, what do you need to know to calculate molecular formula? By elemental analysis, they mean percent composition. What does the empirical formula mass tell you? Okay, so what is empirical formula mass? All right, that's it for really chapter 10 in general. We'll be doing some review this week, and then we will have a quiz over percent composition, empirical, and molecular formula. Okay, and then we will get started a little bit on chemical reactions. Have a wonderful day.